Yeah. Welcome, everyone. Thank you for making DataCon LA 2022. Welcome to the Data for Good track. That's what we have today at this time. My name is Delacqua Kester, and I have my co-host, those two ladies, right, with the yellow shirts on, Nabina, and Nitia. And we'll be moderating the talk, and question and answers we'll ask later or in between. How do you want it?
Yeah, anytime you can interrupt, but if you wait till the end, it makes it easier.
Okay. He'll be talking about tracking the hidden wealth of Russian oligarchs. Mark Quinsland is a field engineer at New 4J who's lucky enough to work on complex and interesting data projects all over the world. Without further ado, I'd like to bring on Mark to the lectern.
Cool, thanks. Oh yeah, here I'll start this guy. Yeah, thanks for coming. I appreciate it. We're recording this on Zoom, so hopefully we'll get a few more people in attendance. Anyway, like you said, my name is Mark Quinsland, and I'm going to be sharing and my screen a little differently. I'm not going to play the PowerPoint presentation because it makes it difficult to bounce back and forth between demos. So I'm just going to go ahead and share it from here, if that's all right with you guys. So, all right, this is me. I'm a field engineer. I've been with NEO for about 5 years. Before that, I did a similar role with data stacks. I have really the best job in the world. I go all over the place helping people at really cool companies solve really interesting problems. And really, NEO is the best job I've ever had. And we are hiring. We are always hiring, looking for data science people, especially if you have graph theory in your background somewhere. But we are, I think we've had 150 people when I started like 5 years ago, and now we're 5 times that. So we're growing fast. So anyway, but yeah, I have really the best job in the world, and we're going to share some of the stuff that we've been using on actual projects. Okay, the ultra wealthy. This isn't really gained, towards people that are doing just low level money laundering, like you might see on Ozark. This is more a different scale. It's just where people are really where they're moving billions of dollars around. We'll talk a little bit about FinCEN and how people are using graph databases. So graph databases are uniquely designed for solving this kind of problem because they focus on the relationships of the data much better than just about any other tool. So talk a little bit about that, show you some of the algorithms that we've been using. And again, we'll kind of work it in. Why is this important to you? Well, you see this green line here? This is graph databases, and this is like SQL databases, relational. They haven't really changed much, but graphs people are starting to figure out, hey, these things are really useful for certain classes of problems. So from a job interviewing standpoint, that type of thing, graphs are really pretty handy. This is a word from our sponsor, NEO again. We're pretty big. We've been used by a lot of different companies in a lot of industries, over 100 million downloads, but we're up there with some pretty top-notch companies who solve pretty interesting problems. There's a lot of government agencies that use us, some with 3 letters. They generate a lot of 4-letter words, those 3-letter companies. But anyway, we do get pretty interesting problems of the kind where really graphs are really well suited to solving them. Typically, we're used for like online recommendation engines, pricing, figuring out what flights you should use, what you should take, what songs to recommend, what books to recommend, lots of different things like that. But also we get used by people looking for fraudsters, looking for financial crimes, trying to figure out, Citibank will give you 10 milliseconds to decide, hey, should I approve this transaction or not? So you have to look at maybe 1,000 different data points. Like I'm trying to do 1,000 table join in Oracle in like 10 milliseconds. This isn't going to happen, but NEO can do it pretty easily. So being able to get this kind of data. And so you've got applications that are doing transactional data, which is also you're doing analytics, and you're trying to use data analysis tools, machine learning and artificial intelligence to try to come up with patterns for like predicting what's going to happen. So graphs are really used for more strategic problems where not just what happened. I mean, Oracle will tell you that but graphs are more of what you want to have happen. You want to influence something you want to prevent something, or you're trying to determine what's going to happen. So you're trying to make recommendations, or you're trying to prevent things. So it's a much more strategic value prop. All right, today's presentation. This is a story of an egg, not an egg from like that you like have in your kitchen, but an egg, a Fabergé egg. This is like from 1899. It's worth millions of dollars. This egg was found on this yacht. This is true story. This yacht was like seized because of who the owners were and where they're trying to put some sanctions on there. That egg was seized, and one of these guys is really pretty angry. So who actually owns that yacht is really kind of a difficult thing to determine. You're trying to see, well, the paperwork says it's this guy here, but really it's probably this guy here who's owning it for somebody else. And so you get into concepts like shell companies and straw owners and that type of thing. But we had a presentation that preceded this one here, and I love your expression that basically when you're high enough up, you don't own things yourself. You pretty much rely on people that work for you that you can have killed if they don't do exactly what they're supposed to be doing. So that's a pretty common structure where people will use their friends to do that. So some of these people are incredibly ruthless, they're incredibly powerful, and I don't think I would really want to be messing around with their yacht even after it was being seized. So when you're trying to figure out who owns this yacht, you start looking at it, and this is where graphs come in. So this is a typical graph where I've got this boat. This boat is called the Amadea. I've got this egg that was there. It was found on this boat. This is registered in the Cayman Islands, which is always a good sign for there's probably something funny going on. On paper, it's owned by this investment company here, which they own another boat, which was also seized. So these are the two principal owners of that type of thing. And you can kind of look. And from there, the trail gets really pretty shady if all you have is public data. If you happen to have a lot of like confidential data, you can it's pretty easy to figure out who the trail is. So a lot of these agencies, when they're trying to figure this out, they use NEO because you start getting into patterns and you start seeing the same names over and over again. And you start seeing the relationships. And graphs are really pretty good because you can just start adding things to it and say, hey, I've got a new company that I've never heard of before, but it's owned by this guy here, or this person here is involved. And you just start putting these things together and you get these massive relationships. And it's like, how does this person know them? There was an old game, 6 Degrees of Separation from Kevin Bacon. You guys know this game, like how many hops does it take? So each person you have to go through, that's called a hop. Like I go through 2 people, 3 people, 4 people. So if you're looking for yachts, it's not a lot of hops to get to this guy here. He's pretty popular, but he doesn't tend to own much by himself. He relies on other people to do that for him. So you can go a couple of hops, but if you're trying to figure out how does this person know this person here, you do a graph algorithms. It's for path analytics to try to figure out what's the shortest path between these people. So if you're trying to do, like look at some of the seized yachts that are out there, start looking to see what companies they own and who owns those companies and how many are those real people, are those fake people, or just straw owners that were brought in for it. So the more confidential data you have, and I have to say that I had a bunch of slides kind of redacted at this point here, so I wasn't allowed to say too much about it, but because a lot of that data is readily available from some of the tax authorities. So it's a big problem, and it's pretty common, and it's not just the Cayman Islands, it's not just Panama, it's just not just these offshore things and other things. The number 2 country for tax shelter setups is actually the US. Chief among those is like South Dakota, Delaware's up there on the list. But this is something that happens a lot. I was in South Dakota a couple of weeks ago, and it's easier to set up a company, a shell company like this, than it is to get a library card. It's just ridiculously simple. And some of the companies that do this are actively involved in trying to create layers to make it harder to do. But almost every company or country is a tax haven in some way or another. So we work with an international consortium of investigative journalists called ICIJ. they use Neo a lot for releasing like the Panama Papers, the Paradise Papers, Pandora Papers. These are all massive leaks where somebody got tired of being screwed over and said, hey, you know what these companies are doing? Who owns this company? So these data sets are readily available, and it makes it really easy to see and write your own queries for doing this. One of these, this one here is kind of a big surprise. This is, I kind of was really surprised at this one. And since I went to a Catholic university, I kind of like, well, this is kind of, let's see what's going on here. This is actually, they're not a huge player anymore. They used to be pretty big, especially during the war. This is the kind of bank that was originally set up for nice charitable purposes, like, well, we need to move some money for this charity that's in this country or this country here. And, you know, because of fighting that's going on. But they use their position as a state secret to be able to like create these shields. So if you had 200 pounds worth of gold that you took out of people's mouths, and you needed to invest it, or you needed to move it to South America safely, these were your guys for doing that. So a long history of that. It's pretty well known. You know, it wasn't just Nazis, actually moved people, war criminals, that type of thing. A lot of corruption going on. So everybody's in on this. I mean, Deutsche Bank, JP Morgan, not B of A, I haven't seen much from them. So we'll talk a little bit about some of the other things that are going on there. But they have been cleaning up, and they've been trying to get better with their transparency. Okay, so here's, I don't have time to demo this. I'm gonna run out of time if I go to all of these. This is a nice, it's called open screening. It's a database that's out there. It shows you some of the people that are, some of the things that are going on, makes it pretty easy to do. I changed my mind. Let's come over here, and you can pick a company like, let's pick Sberbank. That's the bank there. It'll just go ahead and say, what do you know about that? What companies do you have that are involved in this? And so I can click on this and just say, hey, go expand, get all of the neighbors that they have. And I just start seeing, and I can follow down the relationships between these people. How does this person know this person? How does this person know this person? And what kinds of things? So kind of, this is all public data, and they scrape a lot of stuff. There's a lot of open data sources that are out there. A lot of people leak data. So they're trying to use whatever data they have. But there's some other ones that are out there. They've got canned queries for different data sources. This one here is the Duma. It's the Congress. So one of the guys that owned one of those boats is a member of Congress from the Duma. So these are some of the colleagues, and you can kind of see how a lot of times it's not what you've done, but a lot of times who you know and who you can work through to facilitate a certain type of crime. So you know, if you're trying to analyze some of the data, we've got a ton of blog posts out there publishing how to analyze this, how to grab the data, how to run the queries, what kinds of data analytic tools are out there. So all these links, I've got a screen full of links, and we'll go ahead and download it at the end. But anyway, that's how we created Neo. All right, back to Neo. Okay. So yeah, this is Sberbank and some of the relationships they have there. It's a difficult problem, but it's really a lucrative problem for solving. So our company headquarters is in just outside of Copenhagen, and so we're working with the Danish Business Authority. They came to us and said, hey, can you help us with this problem? People are using these complex laws. We can't figure out who the ultimate business owner is, but we think we can reduce our value-added tax loss by $136 million a year. So, I mean, we're talking over $10 million a month. So, like, it's a real problem, and it's with real money. So what they did is they took Neo, and we worked with them. The yellow things here, this is the data that they were able to get. They're scraping data with all kinds of different data sets. So they're looking at corporate reports, they're looking for news articles, anything they can get about describing people, looking for the ownership. So then the gray dots there are classic graph algorithms they're looking for. They're trying to apply this for feature extraction. So Neo gets used a lot for feature extraction for their machine learning. So then the red was actual ML and AI routines. And what they would do is then they would take that information, they throw it back into the graph and just made the whole thing grow. And they just kept expanding on this. And they were pretty successful in their $10 million a month tax reduction. So, but there's a link to it in the bottom if you're interested. Okay. How many of you guys know Ozark, the TV show Ozark? This is not a documentary on tax sheltering or tax avoidance. It's this running a casino to launder illegal cash is so 1940s. Yes, they got that wrong, but it makes for a good movie kind of thing. So, and the reason for that is the law changed with the Patriot Act. And so when they signed the Patriot Act, they're trying to like, hey, we want to know who's shielding money, who's giving money to terrorists, and how is this money moving around? Whether it was intentional or not, the jury's still out on that one. There was a huge tax loophole for property investments. So like if you wanted to buy a $5 million condo, that's now without any trace, that was a big deal. So the old days where you'd walk into somebody's office and say, here's $1 million, I want you to do something for me. Those days are gone. Now it's like, hey, how about your son sells my son a condo? It's a condo worth maybe $500,000, but I'll pay you $5 million for it, and you can do whatever you want with the extra money. And then I'm going to sell it, and you have a friend that's going to buy it from me for $3 million. I'll get $3 million. You get to keep $2. Everybody's happy, and it's clean money. So it's really common. And so people figured that out, that they could do that. So instead of casinos, so they got out of the casino business and they went into the condo business. This is really, really big. So like there's like a billionaire's row, the condos in New York City. There's a substantial percentage that are empty because they're not really used for people. They're used for investments. This is the part that I had to get past the lawyers. So I said, I'm just going to stick to like Twitter quotes, that kind of thing. So if you know of anybody that kind of got out of the casino business, that got into the condo business, making big money selling things to Russians. So that was the accusation. I don't have anything to do with them. Well, yeah, maybe not. So there's actually quite a bit going on. This Trump Tower is one of the few buildings where you could actually sell to in New York using a shell company for moving the money around. This one person here, his name's David Bogatin. He arrived in the US. He officially declared that he had $3 in his pocket. Within a very short period of time, he bought 5 units in Trump Tower for over $15 million. So he's a gangster, and so he probably doesn't want them for himself. But anyway, over a third of the units in Trump Tower were sold to either Russians or Russian shell companies. So it's just well documented. I'm not doing anything illegal, but hopefully I'm not going to get shot at on the way home. But it's one of the few buildings in New York that would actually take money from shell companies. So that tax loophole was, they tried to close it with something called FinCEN. So FinCEN was like, well, there's big loopholes. We want to know when people are actually paying cash. And the banks love this. First they thought, well, this is awful. We got to report all of this stuff. But now what's happening is banks like Deutsche Bank, they don't stop doing it. They file off a FinCEN SAR report and say, hey, this guy here is probably funding a terrorism unit over here. They're moving millions of dollars around. This guy here is doing this. Say, but we did our obligation. We told you about it. So, but stop? No, they keep doing it. So it's a pretty busy, pretty active thing. So there was a leak of SAR reports, and you could kind of see who was doing what. But many very reputable banks are still very actively helping to move billions of dollars around every month. So there's a database of FinCEN reports that are out there. You can analyze, you can go look at it. It's pretty fun to do. But finding a key person in a graph or in a network is really kind of difficult, just because it's like finding a needle in a haystack. But you know what? I'm an engineer. You want to find a needle in a haystack? These things are really good. You know, it's like you could go through it, do it the old way, but magnets are really pretty useful. But there are statistical tools you can use that are kind of the equivalent for finding things in graphs. So this is where you start looking at some of the more powerful tools like the data science, the algorithms that are out there. And so you can identify people that are statistically interesting that you might want to concentrate your efforts on. Because there's way too many people, but if you can narrow it down. So basically what we're going to do is we're going to use relationships, like who does this person know, and where did they go to school, and where do they work, and who else, how many other people that are janitors at that hospital also own clinics, you know, kind of thing. So you can kind of do some interesting analytics. So we're using graph data science, and graph data science is basically taking the graph and the relationships of the data in the graph and using graph algorithms, but also using it as a machine learning pipeline. So you can basically, you can take your typical graph queries that you would run and use the same data to run more interesting analytics and be able to run looking for patterns. So people typically start with knowledge graphs for doing these kind of things, for doing pointers, say, I want to be able to answer these questions. But really what I'm looking for is I want to start looking for, I want to start doing unsupervised ML to where I can say, okay, how is this data structured? Who are the critical people? Where should I focus my efforts? That type of thing. And the holy grail is this guy down here, being able to predict what somebody's going to do, or if you can predict what they're going to do, you can either encourage it or you can discourage it. Maybe it's an illegal activity or they're trying to hack into the network. So most of even our biggest competitors, one of them rhymes with Microsoft and the other one rhymes with Amazon. They use us for their more sophisticated data security problems, like penetration testing and that type of thing. So they use Neo for that, by being able to figure out and predict if somebody does this, and this, you've got a really good chance that they're not going to do this. They're going to surprise you and do this instead. And it's amazing how often you can like set up like honey traps to like try to catch people that are doing this kind of stuff if you can predict what they're going to do. All right. So some of the algorithms that are out there, I skipped a slide, and it's the magic of like, oh, I'm going to keep working on this slide back until the presentation starts. So some of the algorithms, these are the general categories, but pathfinding is a really common one. Like, how does this person know that person? Like, I want to try to do path. How many of you use Google Maps to get here? So being able to find out where something is and what's the next step and that. So you've got like maps for physical things. How many of you get packages through DHL? Like, so they use Neo, like, where does this package go next? Where should this package go next? Where should I route it to? This kind of thing. Supply chain, that's a big problem with shipping and all that kind of stuff. So pathfinding is really a critical thing, and it's really very central to a lot of graph algorithms. So it's pretty basic, but that's the 6 degrees of Kevin Bacon. Like, how do you know this person? And if you are in sales and I'm trying to sell to you, but I don't know you directly, but I can use LinkedIn to find out you know her and she knows him and he knows her. And I can say, hey, I play golf with this guy here and he can introduce me to him, which can then introduce you to you. So being able to do this either as an investigator, as an analyst, or just as a salesperson is a really handy thing. Centrality is another one of those things. And I like to just use the term, these are people that are statistically interesting. Why are they there? So centrality algorithms, that's what made Google extremely rich. So Google competed with Yahoo, and at the time Yahoo was a basic search engine. But Google came along and said, rather than just give you the most recent documents, I want to find ones that are relevant for you. So Google is really more of a recommendation engine. So what they'll do is they'll calculate the page rank to say, hey, how important is this page based upon your criteria? And I'm going to give you your search results. Think about it. When was the last time you did a search on Google and you had to go more than 3 pages before you found what you're looking for? Even though if you type in those words and I type in those words, we're going to get different hits because it takes into context who we are, what we've been looking for, who our friends are, what they've been looking for. Oh, it's evil to some degree, but it's very useful. So anyway, so being able to find out who the key players are. A couple of the key ways of doing that, there's like PageRank is like basic importance. But I love these two because I have to explain them in every project I go to. See these red dots? This is the same graph, but these red dots here, like these guys here, these are like drug dealers. They've got a lot of friends, but they're really low value. They know a lot of people. But these guys here, if you want to isolate this network here, you take out those two there, these guys are gone. So these are your very strategic things. It's like in the political world, these are like the Paul Manaforts of the world, where you've got one group of corrupt people over here, one group over here, and they just kind of make things happen. If you can identify them. So from a people standpoint, that's great. But Cisco is one of our biggest customers. And Cisco said, hey, I'm going to calculate what's the best way to send out things out on this network. I'm looking for these guys here. These are single points of failure. But they're strategically interesting. So if I've got 1,000,000 or 1,000,000,000 of these, but I've got 24 of these, fine, I can hire a team of people just to research these people here. So being able to find out using centrality algorithms is a classic. Community detection is more like feature extraction. I'm trying to figure out how are these things grouped together. So I might say, based upon behavior, these guys over here are really interesting because they've got a little thing going on. They never take any money from anybody else. They just pass it amongst themselves. They just keep doing things. They take money in, they pass it around, they do circular payments. So we solved this for the Brazilian stock exchange. Say, hey, these guys got a little thing going on here, and like, holy crap! Again, it's usually hiding in plain sight. So if you have some math and some graph theory on your side, being able to find teams like that is really pretty easy. So we're trying to do things. And who's most like the other people? This is incredibly complex, but you're trying to calculate similarity. There's a lot of ways to reduce the amount of hits, but if I'm trying to recommend things to you, I'm going to find out movies that I share a lot of things with you. You've seen movies that I haven't seen, so because we have a lot of things in common, these are the movies you're going to recommend. And you might also recommend some things that are like time-based. You might do content-based, and really, when you create recommendations, you take a lot of things into consideration, including similarity. But link prediction is another one that's really handy, where if you've done A and you've done B, but you also have done C, and I've done A and I've done B, what's the likelihood that I'm going to do C? So you can try to predict what somebody's going to do based upon other things. And this is really useful for who's going to churn, who's going to leave, who's going to do something else, who's going to do that next thing, or who's getting ready to do that thing, but they need a little nudge. So you can go ahead and nudge people. But it's also, who should we pay our attention to next week? Who's getting ready to make a move? We should be maybe getting a warrant, that type of thing. So being able to find this thing here and calculate what's the likelihood of this link here forming. Is it statistically likely? Then let's go look at it and assign some people to it. But could lead to a lot of false positives, could lead to a lot of false negatives, and it's really still pretty useful. Okay, embeddings is another topic we are not going to talk about right now. Kind of what I want to do. I've got 3 minutes to go. So this is a lot of this is like you've got basic kinds of machine learning. You've got supervised and unsupervised, and these are our algorithms, kind of where they fit in this scheme of things. And what we're trying to do is to create a work surface for you. You can use ours, you can use Python, you can use your own. What we're trying to do is where you can create processes. The graph data is already there, so being able to take and say, I've got this graph of 1 billion things, it's got all this extra information, and what I need for this particular calculation is like a bipartite graph or monopartite graph. I can go ahead and massage my data and make it pretty easy to use in a pipeline. So this is our latest thing that came out a few months ago. It's a new version of our graph data science library, which comes with the new Python driver. So basically, how many of you guys use Python notebooks? Just kind of curious. But yes, I don't have to explain how that works. Okay, good. But yeah, I spend a lot of time just like saying, hey, look, your data's out there. I can get it to you. This is your connection string. Go talk to the database. Go ahead and just create a graph object here. I want to be able to mutate it. I'm going to be doing some embeddings on it. And then I'm going to go ahead and send the data back to the data frame and be able to visualize it. So it's stupidly simple to do, to go ahead and run. There's obviously other ways to do it, but we try to make it as easy as possible. And I've got 2 minutes left, so yeah, let's go ahead and do that real quick. And when I'm sharing screens, I never know what's going to come up in this. Come on. Live demos are always lots of fun. And I don't see it anywhere. Come on. Yeah, the demo gods are live and well. Let's pull this up. All right, let's do it this way. I see. There it is. Aha, there it is. Exciting. All right, so this is our desktop here. Let's go ahead and just clear this scene because I was playing. And let's go look for that egg. Assets name, springflower egg. There's our egg. Where is it go? Okay, there's our egg. I can see that it's here. I can see who owns it. It was found on this boat here. We can go break that up a little bit further and let's go look for some other people, see what they have. All right. So very quickly, you can start finding little things. This is where, you start looking at the relationships. These happen to be all of the boats that are registered in the same thing using the same shell company. So it's kind of like statistically kind of odd. Sorry about that, but that's my cue for wrap it up. Okay. Okay, cool. So yeah, so the visualization is there. Running the queries is really pretty simple. Let's pull one of those up right now. So if I go to desktop and let's just look at this, I'll pull up the graph data science library, running it from here. Let's go ahead and connect. Yeah, we're good. Come on. The live demo guides are, yeah, select database, it's fine. Okay, let's just go ahead and create run a single algorithm. These are some of the algorithms you want to run, like degree centrality, eigenvector, page rank, article rank, community detection, the classic ones, triangle counting, Leuven, modularity, connected components, path finding, shortest path, similarity for Jacquard, and if you want to do the embeddings we support Node2Vec and FastRP. Let's go ahead and just calculate these let's do, for entities, relationship type any, and let's just use natural, and so go ahead and run. And this is a medium, well, this is actually a pretty small database. There's probably about 40 million records in here. So it's pretty small still. But what it does is it generates the code for you. You can just like copy and paste that and run that from Python, and there's your notebook with the things. If you want to write the data back to the database okay, yeah, all right, I'll stop. Okay, thank you very much. Questions? You have questions, please? Hopefully. Yes. That's a great question. The knowledge graph is really a really generic term, but I'm going to assume you meant like RDF triple star knowledge graph. It's kind of old school. That's probably it because it's old school. It's a great idea in the year 2000, and it never really got beyond that. There's check out his presentation. Did you see it? He did a really good job explanation of why RDFs and they're kind of but we do a lot of RDF to property graph conversions. It's a lot simpler, especially how the property graphs are stored. The query language is easier with Cypher. But yeah, we do a lot of conversions from RDF triple stars. They're fine for that type of thing, but most people don't need the ontologies, and they go through a lot of work creating these ontologies. So if you're like a biotech company and you're wanting to share data and you want to have an international standard way of describing that data, knock your socks off. That ontology is great. It's incredibly complex. But if you're a company and you've got like 20,000 employees, but maybe 10,000 Hive tables, there's other ways that are much simpler. So it's not worth the headache. We're faster, but there's a lot of things that go into. But we get used for knowledge graphs all the time. I mean, probably I'd say 2/3 of my projects start as knowledge graphs, and then they start going beyond that. So it's kind of like the first step, because really it's just connected data plus semantics. So if you take a regular property graph and then you start adding semantics. So we can read an OWL ontology and apply it, but we get used by huge, yeah, we got asked this question, big company that sells stuff for building houses and stuff, and it's like, we've got this ontology, and it was tiny. Like we wanted to use, and it's like, why are you going through this headache for, when you can do something else that's a lot more flexible, a lot faster? Sure. Yeah, I'm sorry, the section not tonight. When I stand right here, I hear that. I'm sorry. Right. Mhm. Yeah. DNNs are, I'm not supposed to really talk about those. We've got a new version coming out in a few weeks, and then they're already working out the roadmap for what's going to be a point release and not what's going to be released. Yeah, they're there. But our library's open, so if you want to write something in Craig, you could just do it. It is like that. And people have done that. I was really like tapped by the presentation. What's the controversial stuff? Last time we talked a little bit about this, something came up afterwards. But what about Hillary? So, it is what it is. Any more questions? Yeah. Well, one of the investigators was killed. Yeah. It's one of those things where, yeah, we haven't had any problems with it. I mean, we've been pretty good. But yeah, there's a lot of people that don't like what we do, and but what we've done is there's this organization, it's called ICIJ, and it's an international consortium of investigative journalists, and they're all over the world. And so people now, like WikiLeaks type leaks, they all go to usually they run them through the Süddeutsche Zeitung newspaper in Germany, and then from there people start working on it. So they'll get a document and they'll start looking at it and say, okay, who's this person here? And they were doing it in Excel. So Neil came along and said, you know what, that was quaint, but we can really help you. So we've had a really good working relationship with them. Yeah, but there is backlash. And I to stand up there and say that my bank, the bank that I bank with, is really corrupt. Let's just say most of the bank is fine. They've got a couple of rogue people doing corrupt things as a cost of doing business, and they routinely pay billions of dollars in fines. But to them, it's just a cost of doing business because they make many more billions. But anyway, yeah, yeah. Yeah, it's like 60 of them. Yeah.
We assume that all the nodes and all of the
No, that's a great question. Yeah, because you have to determine what kind of data. Like here, so like here I have to tell it like this one here, I need a monopartite graph. So there they all are the same type. So basically I can say, take all of these things here and exclude these, use only this. So like I can write a statement that filters it out or adds as much data as I want. I can say which properties to use for weights. So like if I'm trying to calculate the closest in terms of number of hops, or closest in distance, closest in terms of the mileage, there's all kinds of rankings you could use based upon. So it's pretty easy to configure. So like basically you start loading this guy here up here, like for yeah, this property thing would be a much bigger thing. But yeah, filtering out the data and packaging it. So that's why GDS works really well, is because you might have this graph that's got all kinds of relationships that we need for transactional stuff, but for a particular calculation aren't really of interest. So you could basically squeeze all that data out. And really all at that point, I'm just using IDs and pointers So I can really pretty easily fit a big graph like that with billions of nodes in it, in a reasonably sized box. I can run billions of nodes on this guy. It works. Any more? The slides will be out there and what I did, because I had to cut so much stuff out, I stole an idea. So there's the director's cut, there's the bonus material, bunch of slides that I didn't have time to show. So they'll be in the so if you download it, there's like an extra 60 things in there that I was persuaded to leave out. So anyway, but thank you very much for coming today. Appreciate it.
I think we